Fit-2-Fly, it's my CAS project, and as Isaac was so kind to introduce it, I'm looking at automated airworthiness for commercial UAS fleets. We're going to walk through how some of this project came to be. If you're familiar with airworthiness, we're used to using type-certificated aircraft that have an airworthiness certificate, and as long as you use that aircraft the way you're told you should use it within certain bounds, and you maintain it the way you're supposed to maintain it, then your airworthiness certificate stays current and everything's great. If somebody steals a Cessna from you and you find it in a barn 5 years later, even if they've been doing all the maintenance, if it wasn't being done by a certified mechanic who was writing it in the logbook and using certified parts, that's not an airworthy aircraft. You're going to have to tear it apart and kind of rebuild it and figure out how to get an airworthiness certificate on it again. So I first started doing work around unmanned aircraft around 11 years ago when the first low-cost autopilots started coming out. They got down to $2,500. The most recent autopilot I bought was at Target, and the whole vehicle with the autopilot included was $80. And it was much better than the $2,500 one that I was getting back in 2007. But I was really excited about it. I went and talked to our atmospheric sciences people, and I said, hey, who do you have that's a researcher here who has some kind of instrument that I could fly on a drone? I think we should fly science instruments on drones here, and I want to get started. And they said, well, how much can you lift? And I was like, I think maybe 8 pounds, which was a lie. I think probably could have done 5. And he said, oh, that's tough. He said, basically, at this point, my scientists are flying things the size and weight of a full file cabinet drawer, and they're flying them in a King Air, so they don't have to miniaturize them, and they're flying them for $225 an hour. And I said, well, I'll never touch that. So I had to go find another way to make myself useful with drones around NASA. And that was the beginning of a long series of lessons that I learned. Some of those, I was involved in a drone project for a few years that had me working with the FAA and NASA, and also the military on some ranges. And in a lot of ways, it kind of mirrored like being raised by abusive parents a little bit. You're trying to make everybody happy, but you're not sure you can make anybody happy. And you keep bringing them things, and they go, no, that's not good enough all the time. So I think most of us who've been doing research in this area over the past few years knows what that feels like. It's only recently that things have become a little bit more solid and people understand a little bit more of what they need to bring before they're going to start operating. After that, I spent 6 months in a design thinking project that Anna McGowan organized and set up. And we worked with IDEO out here in the Valley, and we interviewed about 70 different people in and out of the industry, trying to form that empathy that you were just hearing about in the last talk. And design thinking is a great tool for finding solutions to problems that have been lingering for a long time, and experts haven't been able to get much traction on them, and you need some new thinking, new approaches that are kind of out of the box. It's also a good way to discover things that people are unaware of, whether they're needs or problems or solutions. And it's also a good way to identify things that everyone's avoiding. So in that design thinking activity that I did with Anna, a lot of things started to pop out of that. Some of them related to that activity, but some of them related to a lot of things I've been carrying in the back of my head for a few years. And that's what's turned into this project that I'll show to you today. So we've heard a lot of activity around the different use cases that I've shown there in photos. I think a lot of these things kind of crystallized into this core set of characteristics for our use case that I've got here. They're all commercial people trying to fly fleets of UAS beyond visual line of sight. They want to fly them routinely, and they want to fly them with a lot of vehicles and up and operating with just a few people. They want it to scale. And this is a bit of a problem. So this is not the kind of thing that's ever been done in commercial aviation before. Of course, it has to be profitable because it's a commercial activity. If you've got to inspect every one of these vehicles and go over it every time it comes back with a certified mechanic, this just isn't going to scale well. It just doesn't work. Every flight effectively is breaking your chain of custody for the vehicle. It flew out there, you weren't with it, you don't know what happened. Did the motor sound funny for a little while? Did someone hack into it? Was it broadcasting all your customers' data for 30 minutes while it was out there? The vehicles themselves are cyber physical systems that are very easy to hack. A data leak as a commercial operator can cost you much more than a crash, much more than a crash. Your telemetry can't be trusted implicitly. You can't believe that. It's the easiest thing to spoof. All your software development toolkits can generate perfectly realistic telemetry because that's the best way to test your software. And of course, the fact that it's all low cost means none of it's going to be certified. So how do we manage this? So if this cartoon that I built here shows this vehicle coming back, how can you trust that vehicle? Do you know what software is loaded into it? Do you know if a motor is overheating? Do you know if it got hit by a bird or shot by a BB? How do you know it's even the same vehicle that came back? These are really important questions. If it was a laptop that you left somewhere in public for a while and came back to it, what has to happen to that laptop before you can trust it again? So the list of things that produce safe aviation are the same. It's the same list for everybody. And anybody that tries to shortcut parts of that list, we all hold up as examples of what not to do when they cause all kinds of problems. So we've got this community of people who want to operate millions of drones in a world where there are only 330,000 aircraft registered already, total, worldwide. Now we want to add millions of drones operated by people who aren't part of an aviation community and aren't part of a culture of safety. So how do we get all this to work so that this future comes to pass? That's really what we're trying to figure out. So our claim is that we rebuild that trust by checking either directly or indirectly every performance critical or safety critical element of the system. Clearly, to do things on that scale, you're going to need to automate it. And clearly, if you're going to automate it, you need to redesign the vehicle and the systems in that vehicle and your concept of operations so that that is possible. That becomes a feasible task. From an airworthiness perspective, that can break down into the questions you see there on the left. Is it made of the right parts? Are there any missing or extra parts? Has everything been assembled correctly? Is it calibrated? Is it configured correctly? Is everything actually operating correctly? Something damaged or worn? Has anything been tampered with? These are all things actually we know how to do. These aren't new questions, but we've got to figure out how to do them routinely and make them easy enough to do so that people who don't understand in their bones how important it is to do it still do it and do it well so that they produce the safe aviation that everyone's come to expect. How this might look in practice might be something like this, where you've got a vehicle returning that's in operation. As soon as it lands, then it undergoes a physical inspection and an electrical inspection to see if things are working well. You grab the flight logs, verify that the data in there is correct. You'd verify that you're running the right version of the software and and the right versions of firmware, and that software is configured correctly. And as we've been looking at this, one question we ask a lot is, how do you go from 0% trust to 100% trust? I don't think you can get to 100% trust without a check flight, and you see that in normal aircraft continuing airworthiness processes at certain points during an aircraft's life or after certain levels of maintenance or repair. You have to do a check flight in order to get an airworthiness certificate on that aircraft. So the other opportunity that we get, and we'll talk a little bit more about the ecosystem all this needs to happen within in just a second, is that opportunity, that check flight, which gives you the chance to say, yes, it is working 100%. This is 100% the vehicle I think it should be, because it is actually doing it. It's hard to get that level of assurance on the ground. You can also do some regulatory compliance work during that check flight as well. So, and I showed a cartoon microphone there. So if you had a restriction in some neighborhood that you couldn't generate more than X number of dB when you're at a certain altitude, at a certain throttle setting, then you could verify for sure that you were not violating that before you were considered ready for your next flight in that environment. So that environment, so we've been looking at how the individual operator, who's a commercial operator trying to make a living doing this and wants a reasonable workload, how they can trust the vehicles that are providing their living and providing the services. We can't do this in a vacuum. We really need to look at this overall ecosystem and look at how everyone needs to have certain levels of trust in that vehicle and in the company that's operating it. So we've got all these different stakeholders in commercial aviation. I've listed just a few of them here. So your national retailers trying to figure out if they want to trust this provider of the service who's also operating these vehicles, they might need to know, is his insurance current? Does his insurance policy cover the type of operations he's promising to do for me? Has he paid his bill? They might need to verify those kind of things in order to trust them in order to do commerce. So the federal regulator might want to review the flight logs monthly to see if they're operating in compliance with the regulations. Local regulators might be more concerned about things like noise or other kinds of issues. Retail customers might just be worried about, what's the flight history for this business? They crashed 4 in the last month or none in the last 2 years. How heavy is this vehicle? If it falls on my house, is it going to damage my shingles? Or is it going to come through my roof and end up in my dining room? They want to know these kind of things in order to trust these services and start to participate in this commercial activity. Members of the general public who aren't part of that commercial activity, as we know, it's very, very easy to generate a lot of paranoia around these types of operations. So there's other needs there that we need to incorporate into the design of this ecosystem. And of course, regulators and people like the person at the local FAA control tower, they have to be brought into this as well. Interesting story. I see that's counting down, I see. Oh, man, I covered a lot of ground for 7 minutes. Sorry. So the first NTSB investigation of a drone loss was a Predator in 2006 near Nogales. And one of the fascinating things I saw in that report is everybody involved had a different idea of what that Predator was going to do when they lost communication with it, how it was set up to operate. And none of them were right. It was set up a different way. But the FAA control tower thought it would follow a certain procedure when they lost contact with it. The people who were operating it thought it would do something completely different. Anyway, it surprised everybody. They finally found it in a ditch near a building. So anyway, it's a great report. There's a lot to learn from it. So to summarize, we really need a solution in this area to meet the needs of all these different people that manages this convergence of aviation safety, cybersecurity, cheap hardware, and all of it being operated by a bunch of people who aren't like us and don't have our background, who don't understand the stakes of operating in the national airspace the same way we do. And we need a solution that solves these problems so well that they greedily adopt these solutions, that they really see this clearly as implementing the business that they want to be able to do. So this is our first take at how we were going to attack this project. We were going to do this theoretical track where we looked at what a digital airworthiness certificate would need to be for this future environment, where the same vehicle never really takes off twice. You don't have a type anymore to certify. How do you manage that? And how do you manage airworthiness that is kind of a sliding scale? So a vehicle may be airworthy enough to fly in the rain, but it's not airworthy enough to fly in the snow or at night. Or it's airworthy enough to ferry itself back for repair at a depot, but it's not airworthy enough to carry passengers. So we need an algorithmic approach to airworthiness that we can process in an automated system on vehicles at a wide range of complexity, and we need it to really meet these business needs. And then, of course, we need to be able to demonstrate some of this in hardware so that people will take the ideas seriously and adopt these ideas. And an important component of this is going to be the onboard monitoring. Since no one is there, no one's on board like they've always been in commercial aviation, we've got to be able to monitor and record what happens to the vehicle during flight. So this is kind of what our product space is shaping up to be. We're 9 months into the work at this point on this project. And we found that to really talk about these things seriously and to lay out serious solutions for them, it needs to be done in an environment that includes commercial-grade drones. It's not something you can really do on the drones of today. So part of what we're doing is defining what that means to be a commercial grade drone. For instance, you shouldn't be single string on anything. If you're going to put a camera helicopter, octocopter up above the Super Bowl with drunk people throwing footballs at it, it needs to be a pretty robust system. So you might have systems that are quadruply redundant and in almost every part of it. Anyway, I can go down a big rabbit hole on that. The other part is the digital airworthiness certificate, and we're building that on a permissioned blockchain using smart contracts. So the actual airworthiness certificate for the vehicle would be a smart contract that was closed. The blockchains might do things like track the supply chain of the motors and then start to encode their operational history in there. Those different people that I was showing that were stakeholders of commercial aviation, they all need different levels of insight into this. So some of that data is going to be proprietary, some of it's not. Regulators might need to see things that others wouldn't. So this gives us a tool to manage that different levels of granularity and different depth of insight into these different stakeholders, and also to be able to audit this and make sure that people aren't getting unauthorized access. We're also pairing this with a harbor pilot model for managing the flight of the aircraft and generating flight releases. This is another thing that I can go into more detail if you come to the poster session. I'm not going to waste a bunch of slides trying to rush through it here. But this is following a model similar to what you see when large freighters come into foreign ports. They'll meet that freighter at the edge of the harbor with a pilot who actually knows how to drive things in that harbor, who speaks the local language, who knows all the procedures, concept of operations. They can safely pilot that freighter in that harbor, not the foreign pilot. So this is a thing that lets us address several of the needs that I was talking about, including the paranoia of the public. So again, I can get into more details if you'd like. And then the onboard monitoring is another really important part of being able to close this out, being able to monitor things acoustically, especially monitoring things in the RF space. It's hard to imagine these things operating without open RF links and connections to multiple networks. So we need to really look and see, is it transmitting 30% more data than we think it is? Are we flying next to some emitters that are lowering our link margin? So we need to replan routes for the rest of the afternoon. So anyway, those are kind of the main components that are starting to emerge from the work that we think will be of interest. We have others as well, but we really are trying to take a hard look at the needs of all those users and see how we can come up with an ecosystem that really works well for everybody. So they'll actually do all those steps, dot the I's, cross the T's, make the computers dot I's and cross T's so they really get dotted, and build in the kind of system that'll produce the levels of safety that, that we're really going to expect for these kinds of commercial operations of these kinds of systems to become routine and boring and look trivially easy. They've managed to do it with 787s, but we need to do it down here. So I'll go ahead and stop there if anybody has questions.
John has one too.
Cool.
I'd like to catch it. So who is showing interest in this? I mean, from an external view, there appears to be a lot of opportunity for this as a system, a variety of individual systems, service-oriented opportunities here to provide this. How have you reached out to the community that could be providing these kind of services? What do you think?
So we've been relatively quiet. We haven't been advertising so far. I've talked to a lot of different groups in the industry. We met at AEVSI with a lot of different companies, found a lot of like-minded folks who were very excited about the project and were interested in partnering. They have specific technologies to come to bring to this. A a lot of the work's already been done for the automotive industry, so we're looking at different consortiums that have been formed there and wondering if those are a good model for us to follow, whether to set up an initiative or a consortium or some kind of working group, talking about putting out an RFI perhaps in this next year. But there's a number of different models we could follow, and we've got good models to follow in other industries who've been trying to address some similar problems. But a lot of the folks who are most excited about operating these fleets of aircraft have never operated fleets of anything before. So they really don't understand how much work it takes to put 9 UPS trucks on the line every morning in Milwaukee behind the scenes and how poorly these things scale. So for the folks who have experience with those types of operations, they really get excited about it and they understand the value of it. And I think for the folks who are not read in yet on the risk and rewards that await them, it's our job to have that solution in place by the time they get there to make that possible.
Thank you.
Thanks. And I think I looked at my notes finally. I think there's a good analogy to make here too between like agile type development, which I think characterizes a lot of the demonstrations that we see today, where you have teams putting together flight demonstrations, to DevOps, which is kind of the thing that the Valley has kind of graduated to, and Netflix has some great materials I'd recommend people look at on DevOps. But it is, I think, this kind of routine fleet operations is much more akin to that, and I think there's a lot to learn there from software development.
One more question.
Yeah, and sort of along that line, I mean, like, think about something like remote ID, right? That's a very political thing. FAA cannot enforce remote ID for these things. But is there, in thinking about this, should there be a level? Should there be like a black box? I mean, we have black boxes in automobiles and aircraft. Should there be, this is a basic, set of minimums that you should have to do this?
Yes, I think we do. I think there's a great opportunity here for that, and I guess I'm hoping that the structure of this ecosystem results in all the incentives being there for people to look, and that's one of the reasons it's so important to keep the focus on commercial applications for this project. Is we want to make it so that the people who do put that black box on are the ones you want to do business with, and that the ones who don't have that black box are the ones that are a lot riskier and you're not sure you want to do business with. So we want to create those kind of incentives and disincentives in the ecosystem itself so that it's not so much the heavy hand of government forcing these things, but market forces that are well aligned and tuned with aviation safety best practices.
It seems like the insurance industry would be a great advocate, a supporter of that, driving that kind of market forces.
Yes, yeah, I believe they are, and they have. I'm sorry, and Marty said it seems that the insurance industry might be an important driver for this kind of market, and I would wholly agree.
Okay.
Yeah.
Thank you.
Thanks.